Cool. We can still talk and all
Good
that, right? You're
morning.
okay with that?
Yeah, we sure can. Good morning, everyone.
Awesome.
We're opening up the webinar because we have quite a few people that are going to be joining today. This is Jim Saprinsky, your host. I'm here with Craig Shallahamer, but we will get started in about 2 minutes. Hope everyone's doing well today. We have an awesome presentation from
That's the
Craig.
plan. Mhm. So what are you doing this summer, Jim?
It's interesting, Craig. This summer, I've been tearing down a boathouse up at our cabin here in Wisconsin. And it's been interesting because it's only been 98% humidity for the past 3 days. So
See you jump in the
that's my
lake in the
project.
middle. Since there's a boathouse, there's a lake, right?
Well, yeah, yeah, you could. It was more of a hornet house because
What was
we
it?
and we had a colony of 7 groundhogs this summer, which is the highest count, and that's one of the reasons we decided to take down the boathouse because we're tired of unpaid renters.
Yeah.
Groundhogs can be extremely destructive, and we have some new neighbors. So anyway, that's my life
So is
these
we
years.
have ground squirrels. Is that the same kind of thing?
Oh no, no, no. Oh no, no. No, no.
Because they're
Groundhogs
destructive too.
are, yeah, oh yeah, they are. Groundhogs are big. They are a good they're almost beaver sized. And they
Oh,
will, yeah, they will eat gardens. I mean, they're very cute animals, but
yeah,
uh,
they're all cute, aren't they?
until they get inside your garage by accident, and then they will eat their way out. But
Yeah. Wow.
we
No,
have
we have
43 participants already. This is
awesome.
looking good. Keep climbing in, folks. We'll get started in just another minute here. Go ahead, Craig.
Oh yeah. So we have ground squirrels, and they're bigger than a normal squirrel, and they're
Mm.
after a while they start to lose fear of like people, kind of thing. Yeah, and they
That's
will.
not good.
No, it's really bad. And they tend, I've had, a house is on like a slope and there's the foundation kind of thing, right? And they start to go like into like, straight, which leads them like right to the foundation. I'm like,
No.
we can't. So I
Yes.
tried to fill the hole with cement. It took 2 bags. I put of cement in this hole. I'm like, where's all the,
Uh,
it was crazy, man. So everybody's got their thing,
yes.
you know.
Country living at its best is what I'd
Yeah.
like to say.
Yeah.
Well,
They're like super, they're crazy, man. Yeah.
all right, it's 2 minutes past the hour. We have an exciting speaker today. We still have several people logging in. Welcome if you're just joining us. But today we have an amazing topic. I saw a preview of this on Tuesday. Craig Shalla Hammer, right? Hammer, not
Yes.
Hamer. Got it right. Uh, is going to be our presenter today. He's going to be talking about how we can use knowledge graphs for smarter artificial intelligence. Craig's the founder of AuraPub and an applied AI scientist. Coolest title I've ever seen for
Mhm.
Viscosity North America. He's also an Oracle ACE director and a really good friend of mine. Really enjoy spending time with them at various events. Next slide, please. And just to bring everybody up to speed, Craig is the latest in our offered speakers. As you can see in our list here, we've had quite a few speakers over the past several months. I mean, years. We literally have 5.5 years worth of presentations. Uh, you can go right to our website, andouc.org/techcasts, and look at all of them. We are recording this today. This will be posted to YouTube shortly after the recording is complete. And you'll be able to go ahead and take a look at that, as well as Craig's slides from today. Next slide, please.
Oh, I was looking at the participants got behind you there.
Yeah, 75 already. Woohoo.
Oh, that's cool.
Another thing about ANDOUC is you can reach out to us several different ways. Obviously, andouc.org is the easiest way to get to us. I've already mentioned the TechCast line, if you will, or URL. I mentioned YouTube. It also has all of our previous TechCasts out there. Literally, some of them, I think I just culled a few from 2018. So, that's way before 23 AI. Wanted to mention also, we have a Slack channel, a public Slack channel, links right here. You can join us and ask questions of Craig, myself, anybody else that's affiliated with ANDOUC. We do have a LinkedIn page as well. We are on Blue Sky, and I didn't add it here, but we are starting to make our presence felt on Instagram. We also have a spatial and graph special interest group out on LinkedIn as well. One more slide for me, one of my more exciting ones. And if you were at Summit 2025 last April, you saw a completely new vibe. I'll just point that out. We had nearly 20 younger college students from California Polytechnic Pomona that attended our conference. And it was an amazing difference. We are looking at expanding that this year to my personal goal, 50 students. We're really hoping that's going to come about. We're working with them actively and also with Oracle and Oracle Academy, but we're also going to have a lot of unbelievably good content. Something AI will be one of the lead topics, I'm sure. The call for papers is open, and I believe registration is almost ready to open shortly, but of course, we're still several months out. If you would like to present, please go take a look at the call for papers. We love having content from everyone. So please save the date. Don't forget to submit a paper if you can. And Craig, I am out of things to talk about. Over to you.
I'm glad, man. It's cutting into my time. Uh, yeah. Hey,
Oh, one last thing. I'm sorry. Please, I apologize, Craig. I said go and then I said stop. If you
oh
have
yeah, questions.
questions, please put them in the Q&A, not the chat. We have several Oracle product managers on hand today who are going to also help me answer those questions. Okay, Craig, officially zipping my lip.
Yeah, well, I can see one question right now. So, are you going to share the slides afterwards? Yes, Jim's going to put them on the AnDOUC website, I'm sure, and they'll be on the ORPUB website as well too. So, um, fantastic. All right. Well, hey Jim, thanks for the intro. Yeah, my name is Craig Shallahamer, and we're going to talk about going beyond vector searches. A lot of us are talking about vector searches, which is a part of this, but we're going to enhance that, and you can get some really interesting things happen. So I'm actually really excited everywhere, and we don't even see it a lot of times. So. All right, so first slide here, what are we looking at? This is actually a property graph of the book Murder on the Orient Express. Now, my goal here is not to say this is really usable, but it's just like, wow, there's a lot of connections, and that's what graphs are actually all about. So what is this? Like, why do I care? Well, hopefully you will see that it relates to AI, relates to property graphs, GraphRAG, which is using graph in our RAG applications. And can you leave now? And of course, you know you can. You just hit the leave button. So, but here's my plan. When I first started going down the rabbit hole on graph, it was very confusing because there's different types of graphs, and I just felt like, and I believe it's true, people just kind of throw out the names, and it's just and there's some crossover, so it can be really confusing. So I'm going to talk just a couple of minutes about that, and then why RAG. And then while RAG is great and everything, it is limited. And I got a neat little slide from a conversation with ChatGPT. I'll show you about that. And then we're going to talk about how to actually leverage graph. And in specific with RAG, it's all about the entity relationships entities. So it's about relationships. And then I'm going to show you how to merge that together with the RAG applications. And because there's so many options, and I want to express to you that there's so many different ways you can actually do this if you actually have control of what's going on with the app you're building. Let's say if you're building it. And then some use cases to see a couple of those. There are a couple of highlighted ones that are just like, wow, really kind of mind blowing to kind of get us thinking outside of what we might normally think you can use this stuff for. And then I'm going to give you a demo, and I actually have the slides of the demo in case, it crashes and burns, and I'll do the demo. It's a recorded demo. I don't do live demos anymore because, your hands start to shake and you can't type and it's just really bad. So I just don't do that. So which is better? And I'm going to compare different in a sense different types of rack strategies to get the response, and you'll be able to see which ones you like better and all that. So all right, and then next steps. We got slides because really the goal is to kind of get you excited about this, and then so what do I do next? And so I want to give you a bunch of links so you can actually take this forward if that's something you actually want to do. So real quick here, I got a lot. I can't talk too much about this stuff, me and viscosity and all that. So I started working with Oracle Tech in 1989. I actually I got a 4-digit Oracle employee ID number. It was a much smaller company then. And my focus was the database. Okay, so most people know me about my performance tuning work, but I always did forecasting type work. And so when machine learning started to raise its head, I really wanted to jump full into that, but I couldn't with being a founder and owner of Bora Pub and all that. So I talked with Viscosity and we worked it out. And so I'm an employee of Viscosity. I'll tell you about them in just a second. So I'm an applied AI scientist, which Jim said is like the coolest title I've ever had. But it's actually reflects what I do because I like build stuff. Like I apply AI. I don't create algorithms. Okay, that's not me. It never has been me. So it's really perfect for what I actually do. I'm an Oracle Ace director, so that's really cool. Um, and you can kind of, read about the rest of the stuff. All of us, if you look back when you really started to, you could just kind of see a little bit of your future, where you were going, what really excited you. In 1990, I was working for Oracle at the time, but I built a tic-tac-toe program I could play, and it got better. And it's just like, wow, this is so cool. But it took forever. So I wrote another player and they played against each other and then they both got better really fast. And then I could play and it was always a tie. So, I mean, at that point, watching something learn that I created was their programmed was just mind blowing to me. And I'll never forget that. Um, which I think is why I like all this AI stuff so much. So wrote a couple books, teach some classes, and I've actually deployed some of this stuff. Believe it or not, I just don't talk about it. And the one of the ones that's public facing is we actually created, or it's a RAG app, really nice UI, and anybody can use this thing. Doesn't cost anything to actually play with it. But it's an Oracle performance tuning AI assistant. Remember, I told you I did a lot of performance type work. Well, I have classes, blog posts, webinars, just anything I wrote, books, and then with viscosity, we loaded in a bunch of viscosity type stuff that's performance related. And that's what Shane uses with the RAG app to actually answer the questions. And because it's not just general stuff, it's like how I actually approach that. It's very different than what you're going to get if you just go to like the internet or go to like an LLM type chat GPT thing. So you can check that out. Just go to, if you just type in Shane AI, I did that in Grok yesterday and it said, it's this Shane AI. It's this, Oracle thing. I'm like, wow, they actually know about it. But if you put viscosity as well, then you'll go right to it. So it's got a really, really cool UI. Oh, and it's got a surfer persona. I'm going to have a toggle on the next one to tone it down because if English is not your first language, it's pretty intense. So Viscosity is a company, full stack, they go anywhere from like Exadata, big rack systems, EBS to MySQL. It goes Postgres goes all the way down, all the way up, all sorts of different type of services. So it's a services company, performance tuning, upgrades, the whole bit. I first met Viscosity during the first release of Oracle's cloud, and they were migrating people to the cloud. I can't believe they actually were able to pull that off. You know, so great people, great content. All right, let's get into graphs. So, like I told you, graphs, when I first started digging into this, it was really confusing because I really felt like, I think it's true, people just use these terms, especially property and knowledge graph and sometimes network graph. They'll just kind of talk about them together, and it's super confusing, especially if you're trying to figure out like what really are these things. So I'm going to quickly go through these, see if I can, well, see if I can explain this to you. Well, I'll tell you where I cross over these as well. So a network graph really is just about an association. And I've created a network graph based on Oracle active session history to do performance diagnosis. A graph like probably like 7 years ago. And the relationships help you spot where there's a problem with performance in the database or within the application. And it's mind blowing. And it's as simple as like Craig is associated with an Oracle user group, and an Oracle user group is associated with Craig. So it's just a network. Okay. But we can go further. The next step is really we talk about what's called property graphs. And there's a lot in this. And that's the beauty of property graphs is there's a ton of information that's compressed literally in just a few words. Okay. So if you look at this, it's like, okay, Craig speaks at an Oracle user group. And notice there's a direction now, right? You see the arrow right here, whereas the network graph, there's no arrow. Okay. So we have direction, we have two entities, Craig, another entity, Oracle user group, and then we have the relationship. Okay, this is key really to this entire presentation. We have an entity, relationship, and we have an entity. And that's called a triple because there's like, three parts, right? Makes sense. And so entity, relationship, entity. And that is like the foundation really for us to use RAG or to use graph in RAG, it's because of these triples, regardless of how they're expressed or stored or whatever. That's kind of at the crux of this. Now we can go to the next level, which is the knowledge graphs. Okay, so knowledge graphs, it's not just like a property graph that's like bigger. Okay, that's really not what it is. A knowledge graph, it's much more structured. It's like the grammar or like syntax, but you don't want it to be super structured. Like, so it's in, like, you don't want it to be constraining, but you want the structure to be like well thought of. Because if you have a non-restrictive structure, there's freedom in the structure. That same structure can be used with different sets of data to get like mind-blowing, I'll just say results from the graph, especially with the LLMs. And that's one of the use cases I'll actually talk to you about. So, and this really shines here if you're using a relational database. I mean, it took me a while, like, hey, it's just like, duh, Craig, because remember these triples, entity, relationship, entity. Well, when I was first designing Oracle systems, we created, right, entity relationship diagrams. I mean, it's like you can't separate that from a relational database. So any relational database has a huge, I'll say, one up on just storing these triples. And then when you have like the Oracle Autonomous Database, which has graph as part of SQL, as well as all the vector indexing and all that. It's just if you got a ton of data and the data is already in the database, it's like you're most of the way there. I mean, the Oracle has done the really techie tech stuff for you. So, all right, so that's a little bit about, so property and knowledge graphs are very similar. So I actually kind of use those back and forth. But that's probably not the best thing, but that's where I'm at right now. So with GraphRAG, we actually use the knowledge contained within the graph and the structure. And the triples specifically is what we can actually use. Really, it's kind of superpower our RAG apps. Okay, so I hope that brings some clarity. Doesn't get it, I didn't add to the confusion. So I'm not going to go through the slide. I just put this, this is generated right off of ChatGPT, and I just added the last little thing there at the bottom. But because people tend to think, because they just start hearing about graph, like, hey, it's this new thing. Like, this is like top secret. No, it's 1736. I mean, it's just like, come on, man. So it's been around for a while. This is just another way to use graph with AI, just about a lot of things. You know, we have AI, but we can, we can kind of superpower it by adding some stuff that's actually been around for quite a while. So I really shouldn't shock us. Okay, so why do we do RAG? Okay, what's the big deal? It's pretty straightforward here. I'm glad you can see my screen because now I can highlight. So let's say I have a question, I give it to the LLM and I get an answer. So you might say, hey, what is Oracle? And the LLM says a prophet. Okay, but that's not really what I was looking for, though. And so with RAG, the question might be, okay, what is Oracle? And then we go and we look at the relevant context or context, right, that I have available to answer this question. And then the LLM should answer then if it's Oracle context. It'll say, oh, the Oracle database is, and it's going to tell me about that. And this is the beauty of RAG. You see, because if you get an answer like a prophet, you're going to say, well, the LLM doesn't know what it's talking about. It's like hallucinating. Well, it's doing the best it can with the actual prompt that you gave it and with the data it has available. And so with RAG, we can reduce the problem of the hallucination and we get, of course, way better answers than that. The other thing that really highlights RAG is that LLMs are really good at predicting like the next word, right? And like, well, why? Well, yes, the architecture and all the techie stuff, but it's been trained on just written text and a lot of it, and we don't even know what it's been trained on because, of course, they won't tell us actually what it's all trained on. And so it knows the next word. But here's the key part. What if the LLM doesn't know your words, right? It knows all the stuff that's out there in Wikipedia, but what if your words, your content, your documents, your data, it doesn't know about? What can be a really good thing? You don't want it to know about your data, but then how is it supposed to answer the question? It can't. Very well. It's going to guess though, right? Unless you tell it not to. So RAG then gives my words, my content to the LLM. And so there's just a couple reasons why RAG is just so important. Okay. And it really, in my mind, it's kind of like this. Most people think that LLMs are just like this big thing used to generate like another really cool thing. All right. It's just like this, throbbing blob, the scary AI kind of blob thing moving around. But it's I don't say it's more than that. I just say that's not right. But I like to break it up and kind of do a split brain thing. LLMs, one way to abstract it is they're really good at language. And that's because they've ingested tons and tons of language. They're really good at that. It's mind-blowing how good they're with language. Okay. But it also has a lot of content, which is like the knowledge in the context. Well, what if we split that? What if we use the language capabilities that every LLM has with our words and our context? We leverage the language, our context, you put those together and we get really good responses. And so that's another way to conceptualize how, RAG works and why it's so good. Okay, so let's get into the processing a little bit. Okay, I'm going pretty quick. That's because I got a bunch of slides here and we only have limited time. So, in a real high level, there's two main, I'll just say processes here for RAG. We have the ingestion of the data, and then we have the request or the query. Okay, we got to get data in, we got to get it out. Okay, so if you don't have just like a bunch of business data, you might be working with things like transcripts and like PDF, HTML, stuff like that. Okay, well, you're going to have to actually take that. You're going to have to do some pre-processing and you're going to store that in some type of store. Okay. Now, since we're going to use this for RAG, we need to be able to do similarity searches. And I'm going to talk more about that because that's key to like everything in AI applications. Okay. And so what happens? Let's say we have like a PDF, we're going to convert that to text, okay? And then we got a bunch of text, but what we want to do is to break up that text into smaller parts, and we call that chunk or it's chunking. But think of a chunk like a paragraph or a page, okay? And then each one of these chunks, we will transform that into a vector so we can do similarity searches. Okay, and I'll tell you how this works a little bit more in just a minute. So you take a bunch of text, we got a paragraph right here, let's say, okay, paragraph, all the text on there. We're going to take that and we're going to transform that into like an array of floating point numbers. Okay, and each one of those floating point numbers is a dimension. So we could actually create a vector with two dimensions, and that would be an x and a y. If it's three dimensions, x, y, z. Okay, and then you have the vector right there. Okay, so but if you want to do this well, you need to have a vector type in your database. You can store it as a string, but a lot of times the vectors, because they have over 1,500 dimensions. That's 1,500 floating points. If you convert that to a string and store it in your database, you can literally have more space taken up by the vector than the actual data itself. And I'm not joking, I'm completely serious about that. And so to have a vector type is key, okay? But that won't scale if it's just a vector. You got to index it in some way, okay? So that's why you want a vector type index. But it gets weirder because some vector indexes, they're great at like storing the data and retrieve it. But if you want to change your underlying data, well, that means the vector is going to change as well. Well, that whole maintenance thing is overlooked a lot of times until you're faced with actually keeping the system up to date. Well, if you have like in the autonomous databases, those vectors get like automatically updated because that's part of when you define the index. So there's a ton of advantages if you got like a giant system, bunch of data to use Oracle for this kind of thing. Okay, I literally have encountered this just the past few weeks. Okay, just using non-Oracle stuff. And it's super frustrating. Okay, so you get the data in there. Okay, so that's the ingestion. Now, how do we get it out? Okay, this is the really, it's starting to get to the really cool stuff. So we have a request. So I kind of have this up here at the top. So we have let's just call it a query. It could be a request, a statement, a question, whatever, but we want a response from the LLM from that. Okay, so we have to actually turn our query, our request, into a vector. Okay, and I'm going to show you more about this. So we have to embed that. Embed is like we're vectorizing it, we're transforming text into a number or an array. Okay, typically floating points. With that, okay, once we've done this, now we can do a search. We can do a similarity search, and what's going to be returned is those chunks of text. Okay, and that's what I'm trying to draw the picture. So you get that, you get some text back from the similarity search. Now, and if you're using a relational database, right, you're going to get like database rows because typically the rows have some of the columns in the rows have been embedded, and that's what you're searching on. So you actually get rows back. It's kind of cool, or the text back related to the rows, whatever you want. I mean, it's a select statement, so you got it all there. So okay, now this is the key thing to RAG here. So what we're going to do, we all know what a prompt is to the LLM. Well, we're going to enhance, we're going to augment, hence retrieval augmented generation. We're going to augment this prompt. I like to call it the super prompt. And there's a bunch of different ways you can create this. From a prompt perspective, from how much detail we want to put in the prompt, it's just all sorts of stuff. But you've got to have the question the query, and you got to have this context. That's right. That's our knowledge that we're going to give to the LLM. So we got our prompt and we got our context, and we're going to give that to the LLM. And hopefully, when it does its magic, we're going to get a really, really good response. Okay. So that's kind of RAG in a nutshell at a high level right there. But if you understand that, it's like you got it. Okay. Okay, so that sounds great, right? You think, oh man, RAG is this thing, it's the best thing ever. Okay, get this, because I knew this was, I was hoping I would get an honest response here, and I did. I did this from ChatGPT probably at least 6 months ago. I said, can property graphs be used to answer questions that LLMs cannot answer? Not answer well. I said, cannot answer. And it said, yes, property graphs can be used to answer questions that large language models cannot answer, okay, effectively. And this is the cool part, particularly when dealing with highly structured, interconnected, or complex data. That's relationships. Relationships are complicated. They're interconnected, highly interconnected. And so what this tells me that ChatGPT was honest here and said, yeah, LLMs are great, but sometimes we can miss it. And graph information helps us do better. That's my takeaway from this. Okay. So, how do we actually do this? And what we're doing, we're going to need to, in a sense, query a property graph or a knowledge graph. Okay. Just say we're going to query a graph and we're going to use that to augment, right, our request. So, we're going to use property graph data to help build that super prompt so we get even a better response from the LLM. All right. I got to take her. Let's see if there's any questions. I got to calm down. My heart rate must be skyrocketed right now. To mix graph and extract entities. Yes. Okay. The first question is, in fact, I'm going to talk about the question mixing relationships with the text. That's such a good question, man. Um, can I use LM to extract a graph? Oh, guys, so good. Yeah. Yes. The answer is we can use an LLM to extract the relationships from data. Gosh, you guys, this is so good. Definitely, we don't have time to really get into this, but I will touch on both those questions. So that was Ben and uh, heck many. I think I might have got that right. Okay, so let's actually kind of go down this relationship rabbit hole here. Okay, so we're going to vectorize. Hey, what does Craig do at Oracle user groups? And so we're gonna vectorize this. And we're going to find the top three closest relationships. Okay, just relationships, no text chunks, just like these triples. And so the super prompt's going to be something like answer, based on these three relationships or whatever, that kind of thing. Okay. And again, okay, this is so cool. You guys are going to love this. And you're going to love the next slide even better. Okay. So, okay, so let's talk about this whole embedding process. This is like embedding in like 60 seconds kind of thing. So we have this text, and some super smart people created a model slash algorithm that can take text and convert it into coordinates on a graph. If it's 2 dimensions, then we can visually see it. If it's 3 dimensions, then we'll start to see clouds and stuff like that. Okay. But in reality, these are like highly dimensional space. We're talking like 1,536 dimensions. So the way I picture this, I'm just kind of floating in space, right? And there's all these points that are just like floating around me, and close to me, far away from me. Okay. Well, I'm floating in vector space and multidimensional space. And each of these points that are around me, they are the embeddings of things like these different sentences right here, these sentences. And when each one of those are vectorized or embedded, they receive a set of coordinates from these embedding functions or models. And that tells us where they belong in the vector space. So while I'm kind of floating in space, really, once one of these, let's say, sentences or phrases or a text chunk get vectorized, they are assigned a set of coordinates. And those are those floating point numbers we were talking about. Okay. And if it's 2 dimensions, then I can plot it. Okay. Now it's important to note that these coordinates, they don't change unless the actual underlying text changes. So they're like fixed in space. Okay. Now, if I have a request, like what does Craig do at user groups, that will be vectorized. And then all of a sudden, like, boom, that point shows up because it got assigned, its vector, its coordinates. Now, so now we have what does Craig do at user groups? And there's all these other points floating around it. Now, the really cool thing, and I actually don't know how they do this. I haven't gotten down this rabbit hole. But for some reason, okay, because that's what the embedding process is supposed to do, is that my request, the other points that are like out there in vector space, the closer those 2 points are, that means they are more semantically or thematically similar. They're relevant. There's the meaning is close. That's if I can really abstract it that way. And so if I say, okay, I just want the top three closest or top two closest, let's say relationships or text chunks, those will be returned. Okay? And they're close to my question. Okay. And so this is kind of the processes you have right here. So this is why the query must be embedded. So that way you can actually do this similarity searches. And here's like the distances right here. Now, the math that's done to give us the distances, that's done in that high dimensional, space. But when we plot it, we have to reduce the dimensionality to 2. So we lose a ton of information. Okay. So actually the closest point may be, the Oregon coast is a great place to live, but when you reduce it to 2 dimensions, it looks like it's far away. Okay. So you just got to be aware of that kind of stuff. Okay. But I digress. Okay. Now okay. This is the mind-blowing part. Okay. So here are my instructions based on the given context. Answer the question, limiting your response to 30 words. Okay. Here's the context. There's the 3, triples basically right here. Okay. And then I have the question, what does Craig do at user groups? So that's my context. That's my query. That's the instructions. That's the super prompt. And so now we're going to leverage the LLM's language capability to create the response. Boom. And it's freaking mind-blowing, okay, how well it does it, this kind of stuff. This is not text chunks. These are just the relationships. If you want to, you can then actually do, and I'll just this. I got to do this quick because we will run out of time. So you can not only have these phrases floating around in vector space, you can actually have the actual text chunks as well. Right? That was one of the questions you guys asked. So not only do we have Craig knows Troy, that's a triple right there. We can also have in a complete like paragraph that's been embedded, and that can float around as well. And then you could say like, okay, I want the 3 closest text chunks and I want the 3 closest triples. And then you can create a super prompt based on that. Is that, that just blows my mind, man. And it does really, really good. So let's talk about basic GraphRAG. Okay. So now we're using graph, which is really kind of what we've been doing, but it just doesn't seem like it's graph. Okay. So this is very similar to the slide I showed you before. Okay, the only difference here is that somehow we need to have an understanding of the graph. Okay, in this case, the relationships. Okay, we're going to get those Okay, if I'm using just text chunks. Okay, now I'm not using like business data in an Oracle database. Okay, you can literally, and this was one of the questions when you guys asked was, can we extract the relationships? Yes, you can. You can test this. Go into ChatGPT or Grok or whatever you want to use. Say, create for me a story or an article with 300 words. It does it. Then you can say, extract the entity relationship triples. Okay? And you can give it the format that you want it to do. I'll give it in a couple examples. Do it, and boom, it'll do it for you. And it does it way better than any natural processing, regex type library, for sure. But it takes a lot longer and it's more expensive, but you get better triples that way. Okay. If your data is already in a relational database, it's like the entities and relationships have already been defined by the design of the application. And so you could actually create a view. It's going to be a pretty crazy view to actually then have those triples like defined for you because the structure and the data is actually already in the database for you. Now, so if you have, I'll say traditional business data like transactions and orders and stuff like this, it works so well. I think that's my new Yeah, this is the first time I showed anybody this slide right here. So if you have like not, and I don't know how to word this, so you just got to kind of just hang with me here. Okay. And this really depends on how you come into AI. If you come into this from like a JSON, from like a PDF or text document perspective, you will relate more to this. First point. If you come from a traditional business data, which is like like orders and products and customers, okay, and your data is already in a relational database, you're going to come into this from a different perspective. Okay. Um, I grew up in this world, but when I started learning about AI, it forced me to go into this world. And now I'm finally getting to the point where I can, merge those two together. Okay. The beauty of this is if you have whether if it's traditional business data or non-traditional business data that you've actually done that chunking, and then you can load that into like the text chunk will be a column in a table or within a row within a table. Well, then you've kind of are on the same level right now. Okay. If you're in the autonomous database, you can actually do RAG and property graph, knowledge graph type queries directly in the SQL. You don't have to do it in Python. You don't have to do all the access query, the vector store. It's like it's part of SQL. You can literally do this in SQL Developer. It works. Okay. And if it's Oracle Autonomous Database, there's no data replication. Like what I've done coming from this side right here, when I extract those triples, I actually have to store those in another table. And then I embed the actual triples. Well, with Oracle, you don't have to do that second step and take all that extra space and processing. It's like done for you. So it's until you've actually like coded this stuff and you can see the differences. I don't think we really appreciate what the Thomas database is actually doing. I know that I actually didn't, okay, till I really started coding this stuff. So let me give you an example here from like a database example. Okay, you have a customers table, orders table, order lines, and products. Okay, so let's take one example here. Okay, like an order. So we have this company who's a customer because this part of the customer table, okay, generates that's a relationship, okay, in order, okay, which comes from the order table. So right there we have one triple. And you can embed that, you can store that, it's already there if you're in the Oracle Thomas database. But we're not done because we got to actually get down to widgets. So we have this order, which is a document, right, from the orders table, is composed of, that's a relationship of an order lines, but we're dealing with one order line right now. Okay, and that's a document type. Okay, I didn't really mention this, but these are like defined like a type of entities, but that's also the table name if it's a relational database, right? Okay, so for each of the order lines, okay, which all right, comes from the order line table, and it's a document type, it contains or some kind of word that tells us about the relationship. Um, a widget, some product, which comes from the product table. So with this one, like if you look at a printed order, right there's at least three triples. And just think about if our and you can literally create a graph of these, right? You can literally, connect them together. That's graph information right there. And just like when I just paste ways you can actually create this. And it's just, but the designers of the RAG app are the ones who actually, do this. And there's are some serious design questions. I mean, even when you say, which columns am I going to vectorize? Am I going to take one column and vectorize it and store that in the table? Or is it going to be, column A, B, and C and vectorize that? Right? We have choices. That's like a new job for somebody in some design area because how that decision is has a lot to do with how your RAG application will perform. And it's just, it's a whole nother design piece here, which I haven't read anything about that before, but you can see it. Somebody's got to make that decision. So the classic RAG is, right, we have a question or a query or request. We get the text chunks and we give it to the LLM. That's like your classic RAG. Okay. And you can do all sorts of variety of things on that to make it perform way better than just that, what I just said. You can actually query just the relationships, as I showed you. And you can query the relationships, and then you can get the text chunks that are similar to the relationships floating around in vector space. So, like, for example, if my question's here, there's a relationship here. Well, there's going to be text chunks closer to that relationship. So we can grab some of those and make those part of the context. So now we're actually taking advantage of the graph and the text chunks associated or close, thematically close with the actual triples. I mean, if you think, you're probably like, what? It just, there's like, I'm going to have so many text chunks when I'm done with this thing, relationship. I can't give all of that to an LLM. That is totally correct. So you need to go through what's called a re-rank process, which is going to make sure when you have a complex question, some of those actual, let's say, chunks and relationships that are given to the LLM in the super prompt, you make sure you can cover all the aspects of the question or the request. And that's what this re-rank process does for us. And without it, it just doesn't work well at all. So, but I can't say anything more about re-ranking because we will just run out of time. Okay. So, but what I want you to get out of this is there's a ton of options for you when you do this kind of stuff. Okay, I think we're actually doing pretty good on time. Amazing use cases. This is the one that I really don't understand, but I want to. And it's intriguing enough that I always tell people about this. And I did check yesterday. The URL is still active for this right here. Okay. And if you want to know, because it talks about this mycelium-based biological material. That's what it actually talks about here. I have no idea what that was. So I just picked my favorite AI and I just asked the question and you can read about it. Okay. So, okay, what they did, okay, this is a great example of just like how far you can go with this and probably further, right? So essentially, some scientists took this is a like a painting right here, modern art painting, I guess it was they called it, and they actually loaded that into a graph. It's going to be a knowledge graph. Okay, how they did that, I have no freaking idea. What's the structure definition? I don't know, but I'm sure it's in that article. Okay, but it got pretty deep really fast. So essentially, they now have the structure, right, based upon that painting in this graph. Okay. Now they took a completely different set of data. They took stuff about biology, so that's like the context, right? The structure was the painting. The data was biological papers and research. And in my mind, thinking, okay, they did like it's like a RAG app or something like that. And they were able to kind of merge those two together. They're getting the data so it fits into the structure that's based on in the painting. And they like discovered new stuff. Like, what? Okay, if that's kind of what going on, um, go here and read about it. Okay, and it's so out there. I think I just got to share that with people. Okay, okay. Here's you're going to see demos like this at especially at Oracle conferences. So we got a Sherlock Holmes book, just not super long one. The story is called The Speckled Band. Okay, so what I'm trying to show you here that I extracted relationships, and there's a bunch of them. This is just like the top relationships. And then I had this question like, what's the likely motive for this particular suspect in the murder of Julia Stoner? Okay. And I used only the top 5 relationships. So that's all was given to the super prompt with the question. And just with that information, it came up with this answer, which is totally correct. I'm like, what? How does it do that? That's because there's a ton of information compressed in each triple, And LLMs are freaking mind-blowing with their language capabilities. Okay. And I always have to say, because a lot of times when people think about graph, we're always thinking about traversing nodes, but there's no node traversal here. It was just entity relationships, entity triples. Okay. So I find that just mind-blowing. Okay. All right. So I'm going to go show you a demo of this is my recorded, and I'm going to show it to you three. We're basically going to have the same question, but we're going to do with just classic RAG where we get chunks. We're going to do just, I'll say just core GraphRAG, just relationships only. And then we're going to do a hybrid, which is going to get just the classic chunks. We're going to get the relationships, and we're going to get the chunks that are close to each of the relationships with all the re-ranking stuff. And which is better? Okay. So with that, let's go for this guy right here. Okay. All right. Guys still with me? Still got a bunch of people. That's good. So I hope you guys are enjoying this. Okay, here we go. All right. So, okay, I always write. Actually, I'm able to do AI coding just rocks, guys. It's so cool. You got an idea, you can code it now. So I wrote this all in Python. It's not even fair to say I wrote it, but I was involved. I collaborated. How about that? So this is my query. Which strategy is better, ASH or AW analysis? Now this comes back from my Oracle performance tuning days, right? There's the active session history analysis, the way to diagnose performance issues, and there's this AWR report, right? Active workload history. Okay, they're both awesome. But I'll say which is better. So we're using just standard RAG. I have the word single query because really when you ask an LLM or any AI service one particular question, it actually generates multiple questions based upon your initial question, which is helpful because some questions say, well, which is better, like ASH or AWR? So it needs to say, hey, tell me about ASH, get some chunks back. Tell me about AWR analysis, get some chunks back. And then it can actually put those two together. In fact, another query would be just my query, tell me about AWR and ASH. What are the differences between the two? And so all these queries are generated and you get a ton of chunks back. And then you go through that re-ranking process. I'm not doing that. I'm just saying, give me the 10 closest chunks based upon this one question. So it's really, I call it dumb rag. It's just like anybody can do it. In most demo apps, this is what they're doing. So anyways, we get it back, and okay, which is better? So, okay, there's the question. You can see that. And yeah, there's the question. It took about 8, which is really slow, but that's not what this is really all about. And so you can see the answer. It's right there. Okay, it's actually a pretty darn good answer, and that's because it's actually pulling from transcripts from my AWR and my ASH class, and so it's just like I make sure when I teach people know the difference. Okay, so that's actually if you read it, it's pretty good, but it's okay. Okay, this one same question, but we're only going to use relationships, and I'm going to grab 10 relationships. Now, just for the sake of this. Always have 10 chunks of text or 10 relationship triples. Okay. I wouldn't do it, I could change those in real life, but I just kind of wanted to have more of an apples to apples. It's a tough experiment. So just the relationship. Okay. Boom. Okay. Now let's go back up to the question. There we go. And it found 10 unique relationships. And then we're going to get our answer. It was actually faster, 6 seconds, but this wasn't about the test. So look at this. I'm excited to help you with this. This was actually a really good answer. Really good answer. And the structure of it is really good because the LLMs are really good with language. And the beauty of this one also is that I especially wanted to show this is that here are the sources and these are the triples. So the super prompt, which I don't show, actually contains all this information. I mean, it doesn't show the source here, but it shows the triples with the parentheses, with the entity, or with the like the products table or whatever, that same kind of thing here. It's the type of entity. And that's what it built the answer on. And I tell it, don't use any other information. So unless the LLM is actually bypassing my instructions, then it's only using this information. Okay. Now we want to get a hybrid approach, which is both. Okay. So we're going to put those two together. There's a lot more going on with this, and it still did it pretty darn. I had to do some re-ranking right here. So let's see, 52 uniques. I got 10 results. No, so it looks like at the very end, well, no, it did use relationships, but at the very end, when it looked at the text chunks related to the relationships, the text chunks were more valuable to answering than just the pure like triples. But some of the text chunks were retrieved based upon the relationships. So it's not that relationships are not important. I was probably really confused the crap out of you guys, didn't I, with that? Okay, so anyway, we're going to go back. Let's look at the answer real quick. Here we go. The answer is mind-blowing. Okay. I love the word here. It said, yeah, that's a great question and a nuanced debate in the world of database performance optimization. And it is, it's nuanced. And this goes on to explain the nuance. And in summary, at the bottom, both strategies are valuable at mastering both makes you golden in problem solving. I can tell that's how I talk about it. Literally, I say the word golden, so it's pulling from my context. And you can say, oh, I didn't show you the sources. No, it is. I must have skipped that, but it literally pulled from the transcripts from some of my classes, and it actually shows you which session and everything. So I wanted to show you the demo, and just in case the demo failed, because I don't give you the video, but I give you what I call the demo failure slides. This is the elements from each one of those that I just showed you, so you can go back and actually look at that. Okay. Oh yeah, here's what the class, ASH class, AWR class, session 1, 2, and 3. So that's the transcripts. So super cool. Which is better? In my experience, the hybrid is almost always the best. Not only does it get the detailed information and I'll say the hardcore relationship information from the triples, but then when you have the text chunks, it adds more language that is related to the question. And so the answers typically are richer and deeper when you have that hybrid. That's just kind of my relationship. So what's next? Okay, if you got a ton of data and it's already in Oracle, it just makes sense to use the autonomous database and use the graph queries that are like right in SQL. I mean, just like I don't know why you wouldn't actually do that. Okay, Jim is going to have a presentation later on about RDF. That's knowledge graphs and stuff like that. So that's going to be super cool. I can't wait until he does that. If you just wanted to kind of explore and kind of look at stuff, I did a blog post. It's on Viscosity's site, which contains some Python code that you can actually kind of run what I did. It's not as deep. It's my first version of it, but it's pretty cool. And if you just want to do something kind of for real, but you don't want to use production database or production data, and you don't have that much data, well, then you have a ton of options. You can use like, if you're familiar with this stuff, like LangChain, Llama Index or vector index, MimGraph, which is a property graph store, so it's native stored in graph. Or what I do now is I use Cursor AI. And I literally have my latest, I'm using SQLite, and this is the Facebook index similarity search. So, which has some issues with maintenance stuff. But anyways, you have a ton of options if you actually want to play with this. Now, if you actually want to touch the Oracle stuff, there's some a lot live labs right here. So you're going to get these slides, but you can screenshot this like right now. Boom. Okay. And you can actually start playing with this. It's amazing because you'll get to see the queries actually in SQL, which is super good. And here's some more resources. Screenshot that. Yeah, I wanted these pictures in my stuff. Oh, Rahul is actually here. Mealy's not here. Jean is here though, so she can help you if you have questions too. So thank you guys for listening. Man, it took up all the time. And Jim, back to you.
Ah, excellent. So just to wrap up real quickly, because we're almost at the top of the hour, we always have some of these helpful links on Oracle Analytics. because it's in our name. Next slide, please. And
Well,
there we go. Just to remind you, one more. There we go. This presentation is being recorded. Almost as soon as it's done being recorded, we'll get it out on YouTube later today. I think actually we will have the slides out there even more quickly. We just uploaded those. So check back in maybe about early tomorrow morning. You'll be able to actually do a replay of this. And one last thing, if I could have the final slide as we wrap up. Just a reminder, hey, you like this content? You like enthusiastic speakers like Craig, other folks that we have here? Let me tell you, Analytics and Data Summit 2026. Again, it's going to be in Redwood Shores at, if you will, quote, old headquarters. We have the call for papers open, but for right now, treat this like a really exclusive wedding, if you will. Save the date. April 14th through the 16th. It's a wonderful conference. It's at the Oracle Conference Center, right by the famous boat that won the World Cup. And excellent food, excellent gatherings, and unbelievable content. So hopefully we'll have you join us next year. There were some other questions in the stack, but I think Rahul and other folks have been jumping on and answering them. I don't think we have any other open questions. Gene's actually typing in one on
nice.
recommendations for re-ranking algorithms, specifically related to GraphRAG. Excellent questions, by the way, folks. Obviously, you paid
Yeah.
attention.
Yeah. I mean, the questions, these are like the best questions I've ever gotten on this stuff.
Yeah, I
Yeah.
agree. Yeah, yeah. And it helps me understand RDF better too, right, Craig? I mean, RDF
Yeah.
and property graphs are different things, right?
Yeah. Hmm.
Similar but different.
Oh,
So,
yeah.
all right.
Oh, these
I
are
think
great
we're gonna,
questions. Wow.
yeah, yeah.
Hey, can we copy those questions? I mean, can we?
Yes, we can. Yes, I will have the transcript. I will definitely have those.
Oh, I want, yeah, those are great answers, Raul and
We will
Gene.
send them over to you. Yeah,
Okay.
for sure. For sure.
Yeah, thank
All
you
right,
guys.
but yeah, thank you, Craig.
Thank you, Jim.
Wow,
Yeah.
this was fantastic. All right, we're going to wrap up here and let you get on with the rest of your day, wherever you might be. Have a great week and weekend, and we'll see you in August on the 21st for yet another great TechCast.
Yeah.